There's 3 different insulation types. The first insulation type, the one that we use the most, is called polyiso. Polyisocyanurate, also called ISO. I'd leave it in that plastic because it does get itchy. ISO is the preferred insulation because it's compatible with bonding adhesive. Everybody stocks it, all the suppliers stock it, and you can get it in tapered and flat thicknesses. It also has higher R value per inch than most of the other installations.
Is there any
Most expensive, right?
No, extruded would be more expensive.
Is there any supply problems like there was?
Not currently.
Okay.
Comes in 4x4 sheets, 4x8 sheets. You can get it in thicknesses from a 1/2 inch up to 4 inches thick. The tapered, your tapered does have to start at a 1/2 inch thickness. Does everyone know what I mean? What tapered insulation is?
Yeah, I would go through it a little.
I would go through it, people like me know.
So like that, you can use that.
So that's flat insulation, right? When they make it, it comes out flat. So imagine these big rollers at the plant. So what they do to make tapered is these rollers would normally be level. And what they do is they set the heights of the rollers, spray the foam out between the facers, let it expand, run it through these rollers, and then it cures. Well, with tapered, all they have to do is pitch one side of the roller. And then they can create this piece of insulation that's sloped like this. And then depending on how much they pitch it, determines what slope you're going with. And depending on the distance, will make up your different tapered insulation panels. In general, for a tapered insulation system, it's a combination of flat insulation and tapered insulation. The primary tapered insulation that we use is a 1/4 inch per foot, and that's because it's code. There are instances where you can get by with an 1/8 of an inch, but in general, push 1/4 if you can, if you've got the height. So how the tapered insulation system on a 1/4 inch looks is you have your first panel, that's an X and a Y. And then the pattern starts all over again. You lay down 2 inch flat, X, Y. And what that will achieve is it's a 1/2 inch start. You guys get the picture? And that's creating your pitch.
So the slope waters towards interior drains or exterior scuppers.
Or a drip edge.
Or
You
drip
can
edge.
hip a roof to all 4 edges.
Yeah. It's meant to move water.
So this is polyiso. You can also get tapered in EPS and extruded, the next 2 types of insulation we're going to talk about. Their system is a little bit different, but it's the same principle. You layer it up. You have a tapered piece, you have a flat piece. Expanded polystyrene, EPS. You've heard of beadboard or EPS before? Think of the white coolers you buy at the gas station. They're chintzy, they're lightweight, they break easily. Same thing with expanded polystyrene, EPS. The reason EPS is nice is it's cheap and you can shape cut it into whatever taper you want or even whatever shape you want. I'd shown you that you can barely see it, the metal retrofit where they have to put a piece of foam in between the metal ribs. That's what you would shape cut EPS. You'd shape cut it with a hot wire and it fits in that flute perfectly. EPS is cheap, but it sucks at R value. You're going to see it more for tapered applications. You see it a lot in ballasted roof systems. EPS is dangerous because it's basically flammable. You know, it can catch fire real quick. The reason that you can't, well, let me back up. You may need a thermal barrier over the insulation or on top of the roof deck for fire code. The state of Minnesota requires you to have a 15-minute thermal barrier between the inside and outside of a building. EPS does not get you there. If you'd have to put down polyiso, an inch and a half of that counts for it. Or put down sheetrock or Denzec. We don't see much EPS. On the small stuff, it's cost prohibitive, there's setup charges, but on a big job, on a big school, you'd see EPS a lot. EPS also soaks up a lot of water. If there's a roof leak and that insulation gets wet, it's gonna suck up that water way more than any of the other insulation products. You can generally tell if a building has EPS on it because when you step on it, it's gonna be squishy. It's gonna be a baluster roof and it's gonna have a little bit of squish to it. Next to EPS is extruded polystyrene. Same chemical composition, just one is expanded in a big container. They put blowing agents in there, pentane gas and steam, and it expands up. But then there's extruded polystyrene. Extruded polystyrene is your blue foam, your pink foam, or your yellow foam. You also have green foam. Everyone know what I'm talking about when I'm saying extruded? Fairly rigid. It does not absorb any moisture, which is really nice. That's why you see it in below grade foundation waterproofing systems and things of that nature. It has a R value between ISO and EPS. Problem is that it's not compatible with bonding adhesive. What happens with both EPS and extruded, you get bonding adhesive on it and it just melts. I don't know if you guys think of licking cotton candy. You know how that just kind of melts away? That's what will happen with this insulation. So with that being said, if you are using EPS or extruded and you're doing a fully adhered roof, you have to have a cover board. If you put a cover board on, additional layer of material to install, plus the cost of that, it just drives the cost up. Whereas you could just put down ISO and be one and done. Again, may require a thermal barrier. Tapered and flat, that gets hot wire cut, just like EPS. Compressive strengths. We didn't touch on that for polyiso or EPS. ISO has a 20 psi compressive strength, but you can also get an upgraded 25 psi. More than likely, you guys are never going to run into a 25 psi. That's when you get into your enhanced warranties from the manufacturer. With extruded, it starts at 25 psi for roofing applications, and then if you get into like plaza areas where you're doing waterproofing or garden roof areas, you may have to go to a 40 psi or even a 60, and they make 100 psi too for real high compressive strength areas. Extruded is sensitive to heat. Back in probably 20 years ago, there was a shortage of polyiso, the agents, the blowing agents. So everyone was turning to EPS and extruded. Well, when you use extruded on a baluster roof, if you put the extruded out on the roof deck and you roll this black membrane out there, that black membrane would get so hot before the rock went on there, it would change the chemical composition of the insulation, and it would make the insulation curl like huge. You could take a 8-foot long sheet and basically almost get the two ends to touch. That's how sensitive it is to heat when it gets that hot. So if you end up using extruded on a baluster roof, you have to cover it with rock right away. Just don't sell it. Sell ISO. Extruded is more expensive, and it has a lot more limitations to it. Any questions? Alright. Moving on in the same insulation type realm, you've got cover boards and thermal barriers. Number one cover board we use, wood fiber board. A lot of different names. Carlisle calls their HP board. A lot of people refer to it as bottom board or chipboard or hardboard. It's the same shit that they used to put on houses for sheathing way back when. It's kind of a junk product, but we still use it. It's inexpensive, it works well, but if it gets wet, it turns to mush. So, we use a lot of fiberboard on deck applications. We want a little bit firmer surface on top, and it'll help spread that load out through the rest of the insulation assembly. Then when they put their sweepers on, everything will be supported. It is compatible with bonding adhesive. It has the increased compressive strength I just mentioned. You can't leave it exposed to moisture. Most products you can. Another product that you see a lot of is Densdeck. That's this product right here. It's basically a glorified sheetrock. It's the same inner workings as a gypsum. The outer face is a fiberglass face, and it comes primed or unprimed. Primed is used for when you want to use bonding adhesive on it. It's super itchy, so again, don't take it out of the wrapper. Comes in 3 different thicknesses: 1/4 inch, 1/2 inch, 5/8 inch. If you need to meet a certain fire rating, if you need a 1 hour fire rating in a commercial building, you're probably going to need to use 5/8 inch Densdeck. I talked about the the Rhino Bond system, doing a layover. Using a 1/4 inch Densdeck is a perfect substrate for that. You can pull the old membrane off as much as you can, or if it's old BUR gravel, you sweep the gravel, get everything loose. You cut slots in that old built-up roof, and then you can lay down this Densdeck over top, and then do your mechanically fastened Rhino Bond system over top of that.
Why you cut the slots?
You cut the slots because if you develop a leak in your brand new roof and it hits that secondary layer that you didn't tear off, it's going to be a nightmare to try to find that leak. Whereas if you cut a grid pattern into your roof system, you're limited to chasing that leak to these 10x10 grids, or however much you cut. Does that make sense?
Yeah.
Make sense?
Yeah, is during like a storm and stuff, is that what they're looking for to be damaged besides like the EPDM or the TPO?
Generally, the hail's not going to affect
It won't.
your single ply membrane.
If it gets to that,
Yeah,
you're probably gonna have more signs of storm damage, I would imagine.
okay.
During a hailstorm, the 2 big things that's going to happen on a single ply roof is all your edge metal is going to get toast, and then you can get some imprints on your insulation. If that insulation delaminates, you have a slight chance to get it covered by hail.
But don't you have to do a core test to even get to that? To the insulation?
Yeah,
How
if
do
you
how
see
do
a hail dent,
identify if it's gonna be damaged?
if you see a hail dent, you'll have to cut that whole assembly out and then peel it back to see did that membrane
Okay.
delaminate from, and even a little tiny delamination like that big, it's not going to affect the system.
But you can do, so working with the engineer guy, so what he does, he'll cut it out, and he'll find an impact or whatever, he'll cut it out, and then he'll freeze dry that membrane, and he'll show the fractures in there, show the webbing from those impacts, so you can get them covered. You just
It's
gotta go through some.
reinforced, right?
You're going to see that on TPO and PVC.
That's
Right.
the odds.
When TPO and PVC get colder, they do become a little more brittle and they can crack, like Colin's talking about. But when it comes to EPDM, a non-reinforced EPDM has so much give, it's not going to affect the membrane. So it's an uphill fight. If you guys want to go that route, by all means. But if you get an engineer in there and he dissects it, it's going to be a tough road to get it covered by hail.
You're better off getting the actual rubber itself covered if there's where that hail hits, and if it leaves like if it marks the actual layer of rubber.
Okay.
No, that's what I'm saying, freezing the rubber, it'll
Yeah.
show those fractures.
Like,
It'll
Insurance
show like the
companies,
webbing on the
underlayment
impact.
will not give a shit about dents in the ISO or anything.
Right.
Right, okay,
I mean, they say you're dead now when you're walking on it, so like,
right.
they don't care.
And if it's a ballasted roof, it doesn't matter if the rock's going to protect it.
Right.
Densdeck, there's also a sister product called Secure Rock. It's very similar to Densdeck, 2 different manufacturers. You can use it as a cover board or a thermal barrier. It is the primed versions are compatible with bonding adhesive, and then you can get hail resistant warranties using it as well. There's also sheetrock, drywall, gypsum, whatever you want to call it. That's sometimes used in the assembly. If you ever go into a gymnasium and you look up and you see a metal roof deck and it has little tiny holes in it, anyone know what I'm talking about? That's an acoustical metal deck. That, by code, has to have a gypsum thermal barrier on top of it for fire rating. A lot of guys don't do it, a lot of architects don't know it, but in a commercial application you need to put down Densdeck or sheetrock there. You don't see sheetrock used much in the applications anymore because the manufacturer pushes the use of Densdeck because they sell Densdeck, they don't sell sheetrock. Alright, what are the three basic types of decking that you're gonna run into? Anyone know?
Wood, concrete, steel.
Yep. So, wood and steel are fine, because you can generally run a screw and an insulation plate to it. But what happens when you get to a concrete deck and you want to do a fully adhered system? You gotta mechanically fasten all that insulation down, right?
Lower down.
You can either hammer drill into the concrete deck, which is gonna be a nightmare and labor intensive and probably not good for the concrete deck, or you can stick everything down with adhesives. So there's a couple basic types of adhesive. The one that we primarily use is called a fast adhesive. It's a two-component, think of it as spray foam. You guys are all familiar with spray foam? It's got an A side and a B side, come together in a gun, spray it out, and then it foams up. You've got some that over foams, like your open cell that you got cut off, and you got closed cell where you just let it foam up and leave it. Just like that, we've got insulation adhesives. Fast 100 is our go-to. Couple different ways you can install it. The easiest one for us is called dual cartridge. Think of it as a giant caulking gun, but it's got both tubes built into it. You got a specialized caulking applicator for it, and it has a static mixing tip. So you screw on this fancy tip, and then the chemical weaves its way down the tip, mixes, it's going through, and then you spray it out, and then you stick your insulation down or your membrane down. Make sense? In addition to dual cartridge, you can get a 15-gallon drum. You can also get 55-gallon drums. The 55-gallon drums require specialized machinery to spray it, just like a spray foam rig for house insulation. Olibond is a one-component low-rise foam. You don't see it much anymore. The manufacturers don't like it, but it's foam in a can. Punch a hole in the can, pour it out. The moisture in the air gets the reaction to start, and then you can start sticking your insulation down or your membrane down. Lime and adhesive, same thing, similar to Fast 100, just different name. Cartridge, box, drums. Oh, bead applied or fully adhered or full spray. Bead applied, it's exactly what it says. You're going to put down strips of this low-rise foam adhesive, you know, either 6 inches down the center, 4 inches down the center, 12 inches down the center, whatever the spec needs to be. Or you can do a full spray. To do full spray, you have to have a spray rig because you have to have a spray gun. With dual cartridge, it's all bead applied. However, if you put your beads at 4 inches on center and you squish your insulation down in there, the manufacturer considers that full coverage because the beads are so close. When that foam squishes down, it'll glue everything together instead of just that one little bead. Good to go? Anyone need to take a break?
Nope.
Now we're going to get into some technical stuff, some nomenclature.